Hello, Math 2. I am Mrs. Bricky, and this video is for Unit 2, Lesson 1. We're going to be solving basic quadratic equations today. So first, I wanted you to just think about if you know that something squared is equal to 36, can you figure out what that something is? Hopefully, just from knowing your multiplication facts, hopefully you know that that would be 6. And if we ask that same question, what squared gives me 9, hopefully from your multiplication facts, you know that that is 3. Well, another way of thinking about these two questions is to think about square roots. We could think of these problems as asking what is the square root of 36 and what is the square root of 9. So if you were in class, we did a bell work where we found some side lengths of some different squares. So if you have a square that has an area of 25, hopefully you realize that that means each of the sides are 5. And if you have a square with an area of 81, the two side lengths are 9. But what if we have a square with an area of 2? Well, if we think about square roots to help us solve this problem, the question that we're wondering is, what is the square root of 2? Well, if we put that into our calculator, if you have this TI calculator, it kind of just spits that right back at you, square root of 2. We definitely couldn't get the decimal equivalent, which would be, or the decimal approximation, I guess, 1.41 dot dot dot. But the square that has an area of 2 does not have a nice integer or whole number side length. It's an irrational side length. So we're going to be using square roots today as we solve equations, so we need to talk a little bit about square roots and simplifying with square roots. So square roots are the inverse operations to squaring. The reason that the square root of 64 is 8 is because 64 is equivalent to 8 squared, and you can see that this root and this power of 2, they sort of cancel each other out. They undo each other because they're inverse operations, and we're left with just 8. And the reason that the square root of 9 is 3 is because the square root of 9 is the same as the square root of 3 squared. The root and the power of 2 cancel each other or undo each other, and so that leaves us with just 3. And you may not have thought about square roots this way, but this is a good way of thinking about them. So not all numbers have nice square roots. So when the square root, sort of like the square root of 2 that I showed you earlier, when you have a square root of a whole number and it's not a whole number, then that result is something called an irrational number. Irrational numbers are real numbers that cannot be expressed as a ratio of integers. They can't be expressed in a fraction form. Instead, if we look at their decimal expansion, that decimal expansion neither terminates nor repeats. So it doesn't end and it doesn't have a pattern to it. So a number like the square root of 5, for example, is irrational. If we think about its decimal expansion, it's 2.236067978 dot dot dot. There's no termination, there's no repeated pattern in this decimal expansion, and so the square root of 5 is an irrational number. But the number 7.22222, it is a rational number. We could write that number as the fraction 65 over 9. That repeated 2 tells us that this is a rational number. So I have some numbers that I just want to classify as being rational or irrational. So the first one is 7,329. Well, any whole number definitely is a rational number. In fraction form, it would just be 7329 over 1. So kind of a boring fraction form, but it can definitely be represented as a fraction. So it is a rational number. Square root of 4, so this one has a root, but we know that the square root of 4 is equivalent to the number 2. So this is definitely a rational number. Just because it has a square root doesn't mean it's irrational. If the square root simplifies, it's definitely a rational number. Okay, our next one is 0.52875. Well, this decimal, it is terminating. It stopped after the 5. We don't see a dot, dot, dot here. So this is a rational number. Rational number. If we wanted to know what this fraction form is, just out of curiosity, it is 423 over 800. So it can be expressed in fraction form. Now, you won't need to come up with any of these fractions or anything. You just need to recognize if the number is rational or not. So 0.52875,313, well, when we have that 313 dot, 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 that means it's an irrational number. That decimal expansion is not ending, and it doesn't have a pattern, so it's irrational. Okay, our next one is pi. Hopefully you learned about pi in your previous math classes. Its decimal expansion is 3.1415928 dot, 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 and so that is an irrational number. 0.333. This is definitely a rational number. Whoops. You probably recognize that as the fraction 1/3. Our next one is 1.2. We've got a bar over the 2. Remember, a bar like this over the 2 means that that's a repeated 2. So this is a rational number. The fraction of that, let me see if I can come up with it. Yeah, it's 11/9, just in case you were curious. And then 3 root 2. If we look at our decimal expansion of 3 root 2, it is 4.24264 dot, dot, dot. So that is an irrational number. In past classes, when you've had an irrational number as your answer, you've probably reported your answer in a rounded decimal form. This might even be true with some rational answers as well, like you've probably been rounding a lot. In this class, we prefer to leave such numbers in their exact form. So if your answer is 3 root 2, that's what we prefer you to give as your answer, not the decimal approximation. I mean, it definitely is approximately equal to that. These have all been rounded to 3 decimal places, but we prefer answers like 3 root 2 or 5 pi or 4/3. So we're only going to report our answers in a rounded decimal form when requested. So try to leave your answers in an exact form. Okay, we're going to work now with simplifying some square roots. While the square roots of many numbers result in irrational numbers, some can be simplified. For example, the square root of 50, we can simplify as 5 root 2. And this is the reason they can be simplified is that the number inside of the square root has a factor that is a perfect square. So the square root of 50, we can think of it as the square root of 25 times 2, because 25 times 2 is equivalent to 50. And then we can actually think about the square roots of those two numbers separately. We can think about square root of 25 and think about square root of 2. Now, the square root of 25 is the square root that we know. We know the square root of 25 is 5. So this is equivalent to 5 root 2. Now, this idea of right here of separating this square root into 2 square roots, this only works if our operation is multiplication. It does not work with addition. So do be careful with that. We can only do this because 50 is 25 times 2, because it's multiplication there. Anyway, we will definitely want to report an answer like root 50 as a 5 root 2, but our calculators can do that for us. So you won't have to be doing this by hand. We'll rely on our calculators to turn these answers into simplified radicals. However, your calculator does not help you simplify variables. So we're going to have some expressions that have variables in them. Um, and so you have to be able to simplify those yourself. So remember that square roots and powers of 2 are inverse operations. They undo each other. So that means if we have something in our expression that includes the square root of x squared, that root and power of 2 can cancel each other out, and that gives us just an x. So, and this works for, any variable. So if we had the square root of y squared, that would just be y. If we had the square root of z squared, that would be z. Now, something that we can't simplify is that if we just have the square root of x, like we can't really do anything to that. There's not a power of 2 for the root to undo. So if we have a square root of x, it's just going to stay as a square root of x. If we had a square root of y, it would just stay as a square root of y. It's just when we have a power of 2 on our exponent that we can simplify. So we have some expressions here that have both a number and a variable under the root, and we want to simplify them. Well, when you need to simplify something like this, we're going to use that multiplication property of roots to help us. And this will probably, for the most part, be something that you're doing, in your head as you get going. But I'm going to write out what we're thinking about to sort of make that visible. And then, when you're doing it on your own, on your homework, you may not show all of these steps. So if we are trying to simplify the square root of 36x squared, we're going to think about it as a square root of 36 and a square root of x squared. Again, because the operation here is multiplication, I can separate it that way. Well, in your calculator or in your head, you know that the square root of 36 is 6. And we just talked about that the square root of x squared, because these are inverse operations, in our brain we can realize, well, the square root of x squared is just x. And then we need to sort of combine those two into our answer. They're being multiplied together, so our answer would be 6x. So the square root of 36x squared is equal to 6x. So let's look at another one, a little bit more complicated. So we have the square root of 20x squared here. So we need to think about the square root of 20, and we need to think about the square root of x squared. Well, your calculator, I'm using calculator orange here, your calculator can help you think about the square root of 20. If you type the square root of 20 into your calculator tells you that that is 2 root 5. That's like one of the ugliest 2's I've ever written in my life. That's a 2 though, 2 root 5. And then in your brain, you have to think about, I use pink because brains are pink, right? The square root of x squared, well, we've got a root and a power of 2. Those cancel each other out, so we have just an x. So this is a little bit tricky looking. We usually don't write our answer like this. Whoops, sorry, that's a little typo. Let me try that again. We usually don't write it like this. Now, the reason we don't write it like that is because, well, in part because people have bad handwriting. And if this root gets a little bit too long, then we have this question of like, is the x under the root or not? So it's more customary in math to write your answer with all of the numbers that are, or all of the parts that are outside of the square root first. So we've got a 2 and an x, and then we put the stuff that's inside the root last. So that makes it clear that only the 5 is underneath the root and that the 2 and the x are not. And the reason that it's okay to do this is because multiplication is commutative. So what we really have is a 2 multiplied by a root 5 multiplied by an x, and the order of multiplication, it doesn't matter. So we can certainly think of it as 2 times x times the square root of 5. And this way of writing it is just a little bit more clear, especially if people have bad handwriting. So like this one looks a little bit better than this. And people are like, wait, is the x under the root or not under the root? So we don't want to write it this way just because of that ambiguity. Okay. So our next one is the square root of 4x. So again, we're going to think about a square root of 4 and we're going to think about a square root of x. So we're kind of separating those two roots into the numeric and the variable parts. And in our calculator or in our head, we realize that the square root of 4 is equal to the number 2, and that 2 does not have a root because the square root of 4 is equal to 2. And then in our head, we have to deal with this root x. Well, the x does not have a power of 2. It's just a power of 1x. So it has to stay put inside the root. So our answer looks like this, 2 times the square root of x. And we can't simplify it any further than that. Okay, we have one last one on this slide. We've got the square root of 45x. So again, we're going to think about that numeric part and we're going to think about that variable part kind of separately for a minute. And the square root of 45, if we do that in our calculator, it's 3 times the square root of 5. And the square root of x, unfortunately, because that x does not have a power of 2 or anything, it just has to stay put. Okay, so in this case, it looks like if I look through these solution or these little notes that I've written to myself, it looks like I have just the number 3 that is outside of the root, and then I have both a 5 and an x that are inside of the root. And so this is how we report our answer, with the 5 and the x together under the root. And we're kind of just using this property that we've been using in reverse. If we have a root 5 and a root x, we can definitely write it as the square root of 5x. And then in this case, we just have that coefficient of 3 with our answer. Okay, so if you look at all of these answers that we just got, you can see that we get all kinds of different combinations of things just depending on the problem that we're working on. We can have an x that's not under a root. We can have an x that's under a root. The numbers can just all come out of the root, or some numbers can stay behind. Any possibility here, just depending on what you're simplifying. Okay, so maybe try some of those on your own, see how you're doing, and I'm just going to proceed on with the video. Okay, so we're going to work now on solving basic quadratic equations. An equation that contains a variable with an exponent of 2 is called a quadratic equation. One way to solve a quadratic equation is to isolate the x by undoing the power of 2. Like right now our x has a power of 2. I want to undo that power of 2. Well, a square root is the inverse operation for a power of 2. So the way that we're going to get the x by itself is that we're going to apply a square root to both sides of the equation to solve for x. But this is a little bit trickier than when you worked on linear equations in previous classes. So when we have an equation like x squared equals 16, there are actually two solutions that make the equation true. So in this case, the first sort of obvious solution is 4, because definitely 4 squared gives me 16. But if I had to think of a second one, there is a second solution, and that is if I take the number -4 and square it, I also get 16. So when we apply a square root to both sides of an equation, we need to insert a plus minus symbol to ensure that we represent both solutions. So when we root both sides, when we're like, okay, the thing I want to do is use a square root, we put this fancy pants little plus minus symbol in front of the root that's with the number. Now, this looks kind of funny. X equals plus minus 4. Well, this is just shorthand. This is shorthand for saying that both x and that both 4 and -4 are solutions to the equation. So it's just it just kind of saves you from writing out those two answers separately. And it's just the way that we report that both 4 and -4 make that original equation true. So we're going to practice some of those. So we have the equation x squared equals 121. So we're going to apply a square root to both sides to undo the power of 2. And when we do that, we're going to put a plus minus symbol on that numeric side. So on this side of the equation, right here, we have the square root of x squared, which gives us just an x, because the power of 2 and the root undo each other. And we chose to use the square root to get that to happen. And then on this side, we have positive and negative square root of 121. Well, the square root of 121 is 11. So we have just found our two answers to that equation. X is equal to positive and negative 11. Again, that's just shorthand for this, that x can be both positive and negative 11. Okay, so we have 529 is equal to x squared. So we're going to apply a square root to both sides of the equation to get the power of 2 on the x to cancel. So I'm going to put the plus or minus symbol always with the number part of the equation, not with the variable. So the square root of 529 is 23. So I have two answers. X is equal to positive and negative 23. And again, that plus minus symbol is just shorthand. It means we have 23 and negative 23 as answers. It's absolutely fine to leave your answer written with the plus or minus symbol, but you just have to know what that means. And it means that we have two answers. Okay, our last one on this slide, x squared is equal to 200. So we want to undo that power of 2 by using a square root. We're going to insert that plus or minus symbol with our root. On the left side of the equation, that root and that power of 2, they cancel. And then in my calculator, I'll see what the square root of 200 is, and that simplifies to 10 root 2. So this means I have two answers to my equation. Those two answers are positive 10 root 2 and negative 10 root 2. For more complicated equations, you may need to do some steps before you apply the square root. Basically, we don't want to do the square root as our first step because this, the square root of x squared plus 11, does not simplify. So we want to undo that plus 11 first so that when we apply the square root, it actually is helpful. So we're going to start by subtracting 12 from both sides of the equation. Well, 61 minus 12 is 49. So on the left side of the equation, I just have an x squared because these two canceled. And now I have x squared equals 49. So now I'm ready to apply the square root to both sides of my equation. And when I do that, I get the solution x equals positive and negative 7. So on that first equation, we had to use subtraction to help us. On this one, we have the square root, we have 4x squared. So we want to use some division to help us. So we're going to divide both sides by 4. So now we have x squared equals 25. And now when we apply the square root to both sides with our plus minus symbol, we get x is equal to positive and negative 5. And finally, you could need to do both. So we're going to use some subtraction right here with the 4. We'll get 7x squared is equal to 182. And now we're going to divide each side of our equation by 7 to get x squared is equal to 26. And now we apply the square root to both sides to undo the power of 2. We'll insert that plus or minus symbol, and we get that x is equal to, and the square root of 26 does not simplify, so that is our answer, the square root of 26. And again, we don't want a decimal here. We want to just keep that exact. Okay, remember you can always check your answer by subbing in. And in your calculator, it would look like this if you subbed in, and in both cases, your calculator should give you that answer of 186. So if you're not sure if you're doing the equation correctly, you can always check your answer. All right, that's it for this lesson. Make sure you know what your homework assignment is for your class and get it done. Let your teacher know if you have any questions. Thank you.